2. Okay. All right. So we talked about the antiderivatives for the trig functions that we had seen last semester. All right. The ones on the, let me go up here. The ones from right here, the ones on the left in yellow, we are familiar with because those were the derivatives of the ones on the right. Okay, the ones on the right, if I find the derivative of those, it's the ones in yellow, right? But since it's antiderivative, it's going the other way. Okay, so that's what we have there. Okay, so using those, now we can answer some, there we go. We can answer some antiderivative questions. Okay, so the first one we did, it was just 4 times sine, right? Move the 4 to the front. Find the antiderivative of sine, which is negative cosine. Bring the 4 back in. We're done, right? Plus c, we're done. Okay. Now look at number 2. Look at number 2. What's the problem with number 2? There's a couple issues with number 2. What's the first thing that stands out if we were going to do this problem? What's one thing? There's a couple things that, if I was doing this problem and all I knew was the power rule, right? Add 1 to the power, divide by the new power, and these guys here, there's a couple things that would throw me off. What's one thing that would, what's one potential hiccup? Might not faze you guys, but what's one thing? The fraction, yeah, the division, right? There is no quotient rule for antiderivatives, right? I think I said that yesterday or maybe the day before. There is no quotient rule. So that's one thing we have to deal with, right? One thing we're going to have to deal with is the fraction, the division sign. That's one thing. What's the other thing? What's the other thing that we're going to have to deal with that could be an issue? Hmm? What about that? Yeah. Exactly, right? If we were finding derivative of cosine squared, chain rule, right? We will put the squared in the front on the out here and then do the chain rule, right? We've done that many times. But it's antiderivatives. And the only trig ones that we know are these guys here. And I don't see any cosine squared. I see a cosine, but I don't see any, I see a cosecant squared, but I don't see anything in yellow where I know the answer. So that's going to be an issue. So those two things are going to be an issue. All right, so now I want you to look back at the problem. Those are issues we're going to have to deal with. But here's the thing. Knowing what you know right now, you can deal with it. What's one thing we can do that would help alleviate that problem? Think about it for a second. Think about it for about a minute. Just think. Write down if you can. Just think about it. What can we do possibly to help solve this problem? Right? Because I want to be able to match it with one of those guys there. And I want to have to deal with the fraction, deal with those two things. Okay, so I'll give you about a minute to see if you can come up with something. There is something you can do, but let's see. I think you guys can do it. Okay. Does anyone come up with anything, or maybe something that would look like something that we could handle number two? Yep, yes, sir.
You turn the exponent into a negative one.
So turn the exponent to a negative. So make it look like this. So like that kind of thing. Okay. Again, that's true, right? We could do that. Not a problem. We could do that. That gets rid of one of our problems, the fraction, right? But then that creates another problem. What's that other problem it creates? Yeah. Hold on to that idea. You're right, but hold on. That's if we had a chain rule for antiderivatives, absolutely. I would say do that right there. Perfect. But we don't have a chain rule. Okay? That's a good idea though. I like what you're thinking though. I like what you're thinking because you're close. Okay? So let's go back. Danya, say what you said again. Mm-hmm. So if I want to expand them, okay? So let's rewrite this problem. What Danya is saying is let's rewrite this problem. So what's the first thing I'm going to write? 6 by itself times, and then 1 over cosine squared of x. So if I rewrite it like that, it's still the same answer, right? I'm just expanding it, right? Instead of condensing it, I'm expanding it. Now, why does that help me? Exactly. What is 1 over cosine? Well, what is 1 over cosine? 1 over cosine is the same as secant. So 1 over cosine squared is the same as secant squared, right? And that one's on my list. That one is one of the ones we talked about yesterday in yellow, okay? So I can rewrite this problem as 6 times secant squared dx. Now that I know that, I can solve this one just like I did the one right before. Move the 6 to the front. Don't worry about the 6. Find the antiderivative of secant squared. The antiderivative of secant squared is tangent x plus c. Done. Okay. That's the thing with trig. Some trig things need to be manipulated a little bit because they might not appear as they look. The way they appear might not work for us, but there's ways to manipulate to make them because there are relationships, right? The reciprocal of cosine secant, the reciprocal of sine is cosecant, the reciprocal of tangent is cotangent, things like that, okay? All right. Okay, so do number 3. If you haven't already, do number 3. I think that one's pretty straightforward. Okay, so that one is just two separate, right? We have two terms. 9 cosine x is one term. That's one problem. Minus 4 sine x is another problem, right? So the antiderivative of cosine is sine, right? because the antiderivative, we go this way. The derivative, we go this way. The antiderivative, we go that way. So sine, so it would be 9 sine x minus, and then the antiderivative of sine is negative cosine. So it's already a minus, so I'm going to make that a plus for cosine x plus c. Okay. So look at this one now. Look at the second one. The second one looks very similar to number 2, right? Again, it's a division problem. It's a division problem, right? So we got to deal with that. Sine, I'm good with, right? Sine, I'm good with. I can find what the derivative or the antiderivative of sine or negative sine is going to be. That's not a problem, all right? Cosine squared, didn't I just do that one? Right? Didn't I just do that one? So how would I manipulate this one to make it okay for me to do, for lack of a better term? How to make it so I can actually do this problem? What would I do? Mess with it a little bit. What would I do to this problem so that I could do that? Mm-hmm. Separate how? So that again, no, negative sign. Oh, okay, I see what you mean. So have a multiplication here and then do another one like that, kind of like I did up here. Yeah, you can't do that one. Yeah, right. We can't do that because it's not a plus or a minus. And we don't have a product rule, right? We don't have a product rule. So how can I do this to match? I'll give you a hint. You're going to end up matching one of these yellow guys when you're done. Yeah, Roman, you got it?
Can't you just expand it so you're multiplying the sine times 1/2 cosine squared?
So, okay, so I'm expanding it. So what did you have when you expanded it? You had negative sign. What did you have first?
Negative sine x times 1 over cosine squared x.
Okay, that works. Okay. And then what do we do from there?
You convert the 1 and cosine squared to secant.
Secant squared. Okay. Then what do we do from there? We can't do that for the same reason Danya said earlier. Like, it would be nice if we could do this. It would be nice if we could do this for this problem. Right? Separate them like that and then multiply our answers. It would be nice if we could do it like that, but we just can't. We can't because it's only available if that was a plus or a minus in there. Okay? You guys are all on the right path, though. You guys are on the right path. We just made a hiccup somewhere. So we can't do it like we did the last problem. That's all right. I'll give you a hint. We want it to match one of the ones from earlier, from the page before, one of these yellow guys. We want our finished answer to match that. So you are definitely going to break it up, but you're not going to break it up that way. Yes, sir.
Can we do negative sine x over cosine x times 1 over cosine?
That's what you're going to have to do, yeah. So you're going to break it up like you guys did here, except you're going to break it up a little differently. Yeah. So just like Sebastian said, we're going to put negative sine x over cosine, only one of them. And then what's left? 1 over cosine x, right? If I multiply those, I get cosine squared on the bottom. Now, why is that going to help me? Yeah, it's a tangent. That sine over cosine, y over x, is equal to tangent. It's going to be negative since there's a negative out there. Yep. The relationship between the relationship of sine divided by cosine is the same thing as tangent. And the relationship of cosine divided by, so if these were flipped, it would be cotangent. Okay, that just comes from the unit circle. Because sine is y over 1, right? Cosine is x over 1. Tangent is y over x. So y represents sine, cosine represents x, y over x, sine over cosine. Okay. That one looks like one we have up here. Right there. Different order, right? But since it's multiplication, they're interchangeable. So I can move, so I got a negative sign in front. So what do I do with that negative sign? So it's this one here. This one's the one we're going to use. So how can I make it look like that using what I got right now? What can I do? First of all, what can I do with that negative to get rid of that negative? Because there is no negative up there. Move it to the front. Perfect. It's a negative or a negative 1. Now no more negative for tangent. And then just switch them because it's just multiplication. Oops. So the antiderivative of secant tangent is secant of x plus c. So negative secant x plus c. Okay, again, the hardest part about 2 and 4 had nothing to do with calculus, right? Probably the easiest part of this question was the calculus, because this part right here was the calculus. When I solved that, oh, what did I do? I just looked on my list, right? This was the hardest part about that, right? Just like last semester, the hardest part sometimes, or a lot of the times, wasn't calculus. It was the prerequisite stuff, right? In this case, it was trig. Okay, so the trig sometimes is the hardest part. Okay, right? Because this question right here was all calculus. That was probably the easiest one you guys had on that page, right? This question right here was half calculus, half trig, right? And that was a little more difficult. Okay, so like I said, it's not always the calculus part; it's the prereq stuff, the prerequisite stuff that is needed to solve the problem. Okay. All right, so let's look at this guy here. So these questions look a little different. They have different directions. But we haven't changed the notes, right? We're still in antiderivatives. So that should give you a hint that we're going to use antiderivatives. Okay? So solve the following differential equations. Well, that's something that we haven't seen yet. Differential equations. I'm going to highlight it. What do you think differential equations? I don't think we've seen it phrased that way, but you have experience with differential equations. What are differential equations?
The equation is different. It was the thing where we were doing the if it's continuous or differential.
Even easier than that. Yeah, I know what you're thinking, but even easier than that. You're right, but even like lower level than that. All it is a derivative, right? So let's give you an example. Let's give you an easy example. Yep, you guys are right. It has to do with derivatives. So let's pick an easy equation. X squared plus 4x plus 3. What's the derivative of that guy? What's the derivative of f of x? Not a trick question. 2x plus 4, right? This right here, is that an equation? How do we know it's an equation? Not an x, it has a equal sign. Yeah, it has an equal sign. If it has an equal sign, it's an equation, right? That's what makes things equations, right? Equal sign. Is it a derivative? That's a differential equation. Okay? We've seen tons of those. We've literally seen hundreds and hundreds of those, right? That's all it is. An equation, that's a derivative. Okay? That's all it is. That's all it means. We're going to see it a lot this semester. The next chapter is all about differential equations, where they say, hey, here is the derivative equation, and you have to do things with it. Okay? But that sometimes they use that sometimes they use differential equations and it kind of throws you off. Don't let it. It's the same thing you guys have been doing since we started derivatives. Okay? Okay, so with given conditions, okay, with given conditions, okay, so we're given the derivative equation, the differential equation. The differential equation is right here. F prime of x equals 3x minus 1. That's the differential equation, okay? They want us to create an original equation, f of x. That's what they want us to do. Right? But they don't want us to have a plus c. They're saying, oh, okay, we know that you're going to put a plus c, but here are some conditions that will give you, so you'll be able to specify it. Okay? Well, we always start with our derivative, right? So how do I go from a derivative to an original? What are the steps I need to do to go from the derivative to the original? I'll give you a hint. It's the title of these sections of notes. Find the antiderivative. Yep. Right? To go up instead of down, we do antiderivative, right? So the first thing we got to do is find the antiderivative of 3x minus 1. So really what I'm doing is I'm finding the antiderivative of 3x. I keep forgetting the dx. And the antiderivative of 1. We can separate them like that, or you can do them together. Okay? So we're going to use our power rule. Add a power, divide by the new power. Minus 1. 1 doesn't have a power. So I'm just going to give it a power and divide by that new power plus c. Okay. Don't need these. Okay. So what that is called, another word for that besides the original, is that's called the general solution. It's called a general solution. It's an answer, right? It's f of x, but it's not specific. This question, they want us to be specific. That's why they told us this part too. F of 2 equals 3. What does that mean, f of 2 equals 3? First of all, there's no f prime, right? It's f. So it's referring to this guy. So what is that going to help us do? There you go. Figure out what C is, right? So we can be specific to this problem. Okay? This is the general solution. Sometimes I'll just ask you, what is the general solution? Okay? Just do what we find the antiderivative, you're done. But this question is different than the ones prior because they want us to find specific to this situation here in blue. Okay? So f of 2 equals 3 means plug in 2 for x and 3 for y. Okay? Plug in 2 for x and 3 for y. And they should be equal to each other. So I'm going to plug in the original. So f of x is y. So 3 equals 3 over 2 squared minus plus c. So I'm plugging in 2 for x. So what it's saying is your specific equation, when you plug in 2 for x, you should get 3 for y. So I plugged in 2 for x. I'm going to finish that out. So 3 over 2 times 4 minus 2 plus c should equal 3. Okay, so I can cancel these guys out. That makes a 1, that makes a 2. So I get 3 equals 6 minus 2 plus c. Combine some like terms. I get 3 equals 4 plus c. From there, you can subtract 4 from both sides, or you can do it in your head, figure out what it is. If I subtract 4 from both sides, I get c is negative 1. So now I'm going to come back to my general and write what c is. So 3 over 2x squared minus x minus 1. And this is the one, this is what we call the specific solution. Specific solution. It's specific to the problem that they've given you. Specific to the situation that they've presented, okay? That's the only difference. How is the second one, letter B, different? How is it different? You just got to start from the second derivatives. Try this one on your own. Try this one on your own. Start from the second derivative and work your way up to the original. They want the original. They've given you enough information. You have enough information to be able to do it. Okay, I'll give you about 3-4 minutes to do that. Give it a shot. All right, so first thing I did was I took where they told me to start, which was the f of f double prime, and I figured out that I found the antiderivative of that. So 2x plus c would be f prime, right? But then they told me some things about f prime. So f prime is 2x plus c. All right. Then they said, hey, if you plug in 4 to the derivative, you should get 0 as an answer. So that means if I plug in 0 here and I plug in 4 there, that should work. So that'll tell me what C is. So 0 equals 8 plus C. Subtract 8 from both sides. That means C has to be negative 8. Okay, that's my derivative. That's my specific derivative. Now I got to do that one more time to get to f of x. Okay, so antiderivative, 2x minus 8 dx. I'm going to do the same thing again. 2x squared divided by 2 minus 8x plus c. Okay. So f of x is x squared minus 8x plus c. Okay. The last piece of information is they said when you plug in 4 for x for the original, you should get -1 as an answer. Okay. So -1 equals, and then x everywhere. -1, 16 minus 32 plus c, -16, add 16 to both sides. That means c has to be 15. Should put a plus c there. So what do you get here? We get 2, wait, right here. F prime is x squared minus 8x plus 15. That's the specific original solution. No more c's because I'm specific to that one. Okay. So that one just had an extra step. That was it compared to the one before. Okay. All right. So we have about 17-ish minutes. I'm going to give you a couple more problems as practice. Okay. Because I've given you some problems, but I want you to try some on your own. We've done them together. I want you to try some on your own. Okay. So find some space. If you don't, just find a piece of paper, notebook or something. There should be some space on the back of that last page if you haven't written on it yet. You can try these there. Okay, let me give you some. All right, so find the antiderivative for this guy here. Square root x dx. Okay, find the antiderivative of that guy. Okay, so the first thing, just like when you're finding derivatives, right? You always change things to powers. If you had roots, change them to powers. Positive, negative, whatever they are, change them to powers so that it makes the power rule a lot easier to use, possible to use, okay? So I changed it to that, x to the 1/2. I separated the 1/2. What I did here was this guy right here, what I did was I said 1/2 times 1 over square root of x, separated like that. So it's 1/2 times x to the negative 1/2. Okay. So I'm going to separate them. So the first one is x to the 1/2 dx. You know what? I don't have to separate them. You can if you want, but I'll just break them up like this. So the antiderivative of that guy is add 1. So if I add 1, I get 3 over 2. Divide by 3 over 2. Okay. 1/2 is there. Add 1, I get 1/2. Divide by 1/2, which is the same as multiplying by 2. Okay. Done. Calculus is done. Now I just got to clean up, simplify anywhere I can. The first one I can't do anything. The second one I can. These guys simplify just to be 1s. Okay. All right, let's try at least one more. Let's see here. How about this one? X to the 4th minus 3x squared plus 5 divided by x over 4 dx. Okay, so how do I get rid of division, the fraction? How do I get rid of it? Because I don't have a quotient rule. So there's a couple ways. There's 2 ways that I know. Either way works, but what's one way to get rid of the division? I think we did one like this in our notes. Yeah, I know we did. I think the one in our notes was harder than this one though. What do we do to get rid of division? Because we got an issue with division, right? What's one thing we can do to get rid of division so that I can use the power rule? Yeah, make the exponent negative. Exactly, right? There's one way I can do it, right? I can do this. X to the 4th minus 3x squared plus 5. Make this guy negative and move it to the front. Right? So then what I would need to do is do distributive property, right? Distribute that. That's one way to do it. That'll work. I think that's the way we did it in our notes. The other way is to do this. 4 is x to the 4th is being divided, everything up here. Every term is being divided by x to the 4th. So I'm going to give them each an x to the fourth. Right? So this guy here is just makes a big 1. This guy here, these powers go away. These powers become 2. The last one, just so what it would simplify to is 1 minus 3 over x squared plus 5x to the fourth. And then I would move those powers up. So 1 minus 3x to the negative 2 plus 5x to the negative 4. Which is the exact same thing you would get if you did this, if you distributed it over here. If you distribute it over here, what's x to the negative 4 times x to the 4? What do I do with those powers? That's not the bell. We have 5 more minutes. I don't know why that's the shuttle bell. What do we do with these powers when I distribute? Add them, right? So the first one would be x to the 0, right? The next one would be x to the negative 2. And the last one would be x to the negative 4. That's exactly what I have down here. Isn't x to the 0 power the same as just positive 1? Okay. And then go that way. And then I still need to use the actual, so I would get x minus 3 x to the negative 1 over negative 1 plus 5x to the negative 3 over negative 3 plus c. So it would be x plus 3 over x minus 5 over 3x cubed plus c. Okay. So again, calculus part was right here. This line right here where I found the antiderivative, where I just used the power rule, that was the calculus part. That part wasn't so bad. You add 1 to the power, divide by the new power. That part's not that bad. But sometimes the presentation makes it a little bit more difficult. Okay? All right, so this is what we're going to do. Tomorrow, I haven't assigned anything for this section because tomorrow in class, I'll give you some time to work on it. Okay, so we're not going to do any new notes tomorrow. I'm just going to give you some time to work on the assignment in class. Okay, so I'm not going to assign anything tonight. I will assign it tomorrow in class. Okay, all righty. All right.